Assalamu alaikum students. Welcome to the 14th lecture of Artificial Intelligence. I hope you are fine and enjoying these video lectures of Artificial Intelligence. I am Muhammad Umar Farooq, lecturer Computer Sciences, University of Education, Lahore. So if you have any question regarding any topic, you can send me an email. Inshallah, I will try my best to answer your questions. So in our previous lecture, we solved the 8 puzzle problem by using the heuristic values. The 8 puzzle problem, the initial state is here and the goal state is here. There are total 9 boxes, the 8 tiles and 1 box is empty. Each tile have digit from 1 to 8. So this is our initial state, and just look at this, the goal state. We want to move from this state to this state. So we solve this problem by using the heuristic values. There are 2 ways to calculate the heuristic values, as we discussed in our previous lecture. The first way is the number of misplaced tiles. So this method, the heuristic value is admissible, and the second way to calculate the heuristic value is the sum of distances of the tiles from their goal position, and the distance is the Manhattan distance. So we solve this problem by using these heuristic values, these heuristic function, and that was the end of the 3rd chapter of this book, Artificial Intelligence: A Modern Approach, by Russell. So in our previous chapter, the chapter 3rd addressed a single category of problems where the environment is observable, deterministic, and non-environment, where the solution is a sequence of actions, and the focus of this chapter is only to find that sequence of actions that leads from initial state to goal state. That on the other hand, we can say that the focus of that chapter, this chapter number 3, is to find the path from initial state to goal state. तो हमारा जो फोकस था वो हमारा ये था कि इनिशियल स्टेट से हम किस तरह से सेट ऑफ एक्शन लगाएं, सीक्वेंस हमारे एक्शंस क्या होने चाहिए जो कि हमें गोल तक पहुंचाए. सो what is the meaning of deterministic? We talked about this concept in our lecture number 3. So मैं यहाँ पे उसको just revise कर लेता हूँ. So what is the meaning of deterministic? That the environment, if we are at state A, if we can determine the next state from that state A, then the environment will be deterministic. So, but in this chapter, we will cover one topic, that is the local search. So, what is the local search? To evaluating and modifying one or more current states. So, in this search technique, our focus is only to evaluate the current states, not exploring the as a whole path from initial state to goal state. So, our focus is to explore only current state, to evaluate only current state. So just look at this point again, that evaluating and modifying one or more current states rather than systematically exploring paths from initial state. So हमारा जो focus है अब path के ऊपर नहीं है, just our focus is only to explore or evaluate the current state. So just look at this point. This is also a very important point, that it is good for those which requires only solution instead of path. That मैं एक ऐसा person मेरे पास आता है जो कहता है just भाई मुझे गोल दो, गोल का बताओ, मुझे path को रहने दो. तो for that person, the local search is a very good technique. So to solve that problem, so it evaluate only current state, so that's why it required the less memory. So just look at this point, that move only to neighbors of that node. So क्या करती है कि उसी नोड को, करंट नोड को सेव करती है, और उससे जो हमारे पास नेबर्स के अंदर जो पॉइंट्स होते हैं उसकी तरफ हमारे पास जाती है, बजाय इसके कि पूरे नोड्स जो है उसका पाथ जो है उसको सेव करे वो. So the local search algorithms so includes the methods inspired by statistical physics. So and the second point is that the evolutionary biology. We will cover a topic of genetic algorithm. इंशाल्लाह जो हमारी थर्ड टेक्निक होगी वो हमारे पास जो है वो genetic algorithm की होगी local search technique के अंदर. So look at this slide that the advantages of local search. So it requires a little memory. The second point is it finds the reasonable solution in large or infinite state space. Mean if there is infinite space. So the local search technique is very useful to find the solution. तो अगर हमारे पास जो है वो इन्फिनिट स्पेस आ जाए, कंटिन्यूस स्पेस आ जाए, तो वहाँ पे भी हमारे पास जो है वो रीजनेबल सोल्यूशन फाइंड करती है. सो इट फाइंड द रीजनेबल सोल्यूशन इन लार्ज और इन्फिनिट स्टेट स्पेस फॉर विच the systematic algorithms are unsuitable. So the DFS, DFID or informed search are not suitable for that search space, which have the infinite search space. In the same way, it finds the approximate solution. So this is a very important point that the in local search technique we always try to find the approximate solution, not to find the exact solution. So in the same way, it is a local search method because it save only current state. The last point that is it use the greedy approach. So ये भी हमें क्या करेगी, ये सर्च टेक्निक भी क्या करती है, ये उसको यूज करती है, ह्यूरिस्टिक वैल्यू को यूज करती है. दैट्स व्हाई द लोकल सर्च मेथड इज आल्सो अ greedy approach. So in our local search technique, we will cover these algorithms which are hill climbing, beam search, and genetic algorithm. So in this video lecture, I will cover the hill climbing search. So the hill climbing, जैसा कि नाम से जाहिर हो रहा है कि पहाड़ के ऊपर चढ़ना, तो हमारी कुछ एग्जाम्पल भी इसी तरह की होंगी, यानी कि उसको देखते हुए बनाई गई होंगी. So just look at this point that if the goal is at the top of hill and our agent or robot is blind or blindfolded, and the second point is that at each step, this is a very important point, that at each step it will try to reduce the remaining distance to reach at goal state. So just look at this slide that if the goal state is here at the top of hill, our agent or robot is blind or blindfolded, ये अंधा है या तो फिर उसकी आंखों के ऊपर पट्टी बंधी हुई है. So for example, if the starting state is here, so at each step our robot will try to take that state. ये हमेशा ट्राई करेगा कि the remaining distance from the goal state क्या हो कि वो कम से कम हो, उस स्टेप को सिलेक्ट किया जाए. So it will always select that step that will reduce the remaining distance from the goal state. So the third point is that it know only current state, or we can say that the hill climbing search technique will work with local domain. So it know only about the current state, this our state, our जो हमारी स्टेट स्पेस है वो हमारे पास इन्फिनिट है, but this search technique will know about only the current state. So hill climbing also use the heuristic values, heuristic measurement. That's why the hill climbing is also a greedy search. So these 4 points are similar to these points, which are the advantages of local search. It use the heuristic value, local search method. It will find the approximate solution. Just इसकी एग्जाम्पल भी हम देखेंगे. सो दी स्टेट स्पेस हमारे पास जो एज ए होल देखें, यहाँ पे हमारे पास जो पहाड़ है वो क्या है, वो उसको देखें तो ये हमारे पास इन्फिनिट स्पेस बनती है. तो कितना उसकी हाइट है, कितने उसके पॉइंट्स हैं, कंटिन्यूस कितने मीटर है, कितना वो हमारे पास जो है वो स्पेस जितनी भी है वो सारी की सारी हमारे पास इन्फिनिट बन जाती है. सो दीज आर दी पॉइंट्स अबाउट द हिल क्लाइंबिंग. नाउ आई विल डिस्कस दी algorithm of hill climbing. So just look at this algorithm, the hill climbing algorithm. We will mark the initial state as a current state, then loop do. So a highest valued successor of current state, we will mark that node as a neighbor. So and if the neighbor value is less than the current state, then we will return the current state. Otherwise our neighbor will become the current state. So in the same way the current state दोबारा फिर हमारे पास क्या करेंगे, उसके हम हाईएस्ट वैल्यूज को देखते जाएंगे, उसको नेबर कर देंगे. जैसे ही हमें क्या मिले ये कंडीशन, जस्ट लुक एट दिस कंडीशन, इफ द नेबर डॉट वैल्यू इज लेस देन द करंट वैल्यू देन वी विल रिटर्न द करंट स्टेट. हम इस लाइन को दोबारा फिर हम अपने एग्जांपल्स के अंदर भी देखेंगे. तो जस्ट लुक एट द एक्सप्लेनेशन ऑफ दिस एल्गोरिथम, that the hill climbing search algorithm, which is the most basic local search technique. At each step the current node is replaced by the best neighbor. So at each point, at each state, we will replace the current node by a best neighbor. In this version, that means the neighbor value, uh, that means the neighbor value with the highest value. But if we are using a heuristic value h, so we would find the neighbor with the lowest h. So just look at this point again. If the neighbor value is less than the current value, if we are using the heuristic value, then the condition will become the greater than. So in the same way, the highest valued successor, this value, this point, this condition will also change in the case of heuristic value. If we are using the heuristic value, lowest valued successor of current state, that node will mark as a neighbor. So अगर आपको इसकी समझ नहीं आई तो just look at this slide. इसको थोड़ा सा यहाँ पे elaborate किया गया है. They define the current state as an initial state. So loop until the goal state is achieved, or no more operator can be applied on the current state. So there are two conditions to terminate our algorithm. The first is if we achieved our goal state, and if we are not able to apply our operator on current state. So there are two conditions. So apply an operation to current state and get a new state. So at each point, at each current state, we will apply our operators and we will generate a new states. Then we will compare that new states with the goal to check whether it is a goal or not. Then if we find a goal, then we will quit this algorithm, quit this loop. So evaluate the new state with the heuristic function and compare it with the current state. So these 2 points are very important. Evaluate new state with the heuristic function and compare it with the current state. If the newer state is closer to the goal compared to the current state, update the current state. So if क्या हमारे पास जो नई स्टेट जनरेट होके आई हैं, वो अगर हमारे पास क्या है कि अगर हम उसको गोल के साथ कंपेयर करेंगे और अगर उसकी क्या है वैल्यू जो है वो क्लोजर हुई है गोल की तरफ, तो अपडेट करेंगे. सो इफ द न्यू स्टेट वैल्यू, सो इफ द न्यूअर स्टेट इज नॉट क्लोजर, द अनदर केस, जो दूसरा केस है जो है वो क्या है कि अगर ये क्लोजर ना हुआ, देन क्या है कि हमारे पास वो ऑपरेटर हम उसके ऊपर अप्लाई नहीं कर सकते, तो करंट स्टेट हमारी अपडेट नहीं होगी. जब हमारी करंट स्टेट अपडेट नहीं होगी तो यहाँ पे हम ऑपरेटर अप्लाई नहीं कर सकते उसके ऊपर. तो हमारी करंट स्टेट की चूँकि अपडेट नहीं हो सकती, तो इस तरह की हमारे पास जो है ना, हम इसके ऊपर मजीद बात भी करेंगे, इसके एग्जाम्पल के दौरान इस चीज़ को हम डिस्कस भी करेंगे. So just look at this tree, the problem in which we are moving from starting state S to goal state M. So these values 9, 11, 7.3, 8.5, 8, 7.1, in the same way 9. These values are heuristic values for these nodes. For example, the 9 value is the heuristic value of A. In the same way, the 11 is the heuristic value of B. So we will solve this problem. The problem is we will move from initial state to goal state M by using the heuristic values. So we will solve this problem by using the hill climbing search. So S is our initial state. So I will mark this state as a current state. Then I will, so according to this algorithm, I will mark the current state as a initial state, initial state as a current state. So यहाँ पे मैं loop apply करूँगा. Then I will generate these two nodes जो कि हमारी नई nodes होंगी. Then I will select the best node. So best node कौन सी होगी? Which have the lowest heuristic value. Then I will move towards this node. So I mark the red color over here. So then I will check whether it is a goal or not. If it is a goal, then I will terminate our algorithm, but A is not our goal state. So then I will generate, क्या करूँगा मैं इसको generate करूँगा उससे नई states को. So जो मेरे पास नई states generate होंगी, then I will compare the heuristic value with this node. So just look at this point, the 7.3, 8.5 and 8, all of these three values are less than 9. So I will pick one of the best node. For example, 7.3 have the lowest heuristic value. I will select this node and move towards the C node. So just look at this point. I just check the A node whether it is a goal or not. Then I mark the red color to represent the movement of our agent, our robot, towards the C node. So because C have the lowest heuristic value among all of these three nodes. So then I will check whether the C node is a goal state or not. So C is not our goal state. Then I will just generate these nodes जो कि हमारी next हमारे पास states होंगी. Then I will compare the heuristic values of these two nodes with our current state. So current state से चूँकि इसकी value जो है वो कम आई है, so then I will pick the best node. Best node mean which have the lowest heuristic value. So I node have lowest heuristic value among these two nodes. So I will move towards the I node. So then I will check whether this node is a goal state or not. So the I is not our goal state. Then I will generate these two new states. So जो नई states generate हुई हैं, then I will compare the heuristic value with this. So जो कि हमारे पास जो है वो इससे कम है, और उसमें से हम क्या करेंगे, जो lowest हमारे पास जो value होगी उसको pick करेंगे. तो यहाँ पे हमारे पास क्या है, M को हम select करेंगे क्योंकि heuristic value is 0. So then I will move towards M state. So M is our goal state. Then क्या कर दूंगा मैं, just यहाँ पे इस algorithm को terminate कर दूंगा. So we solve this problem by using a hill climbing search technique, which is a example, which is a search technique belongs to the local search algorithm. So here is some weaknesses of hill climbing search, which are very important. That local maxima, local minima, lateral problem, ridge problem. So now I will discuss these weaknesses one by one. So just look at this point, that if this is our problem, that we want to move from initial state to goal state. Goal is at this position, at this location. So our starting state is here. So जैसे ही जो robot है वो हमारे पास move करता है, at each step it will try to gain the height. So जो हर स्टेप को चलते चलते वो इस लोकेशन पे जब पहुंचता है, तो एट दिस लोकेशन क्या करेगा, जिस तरफ मर्जी वो मूव कर ले, चाहे वो इस तरफ जाए चाहे वो इस तरफ जाए, तो हाइट जो है वो गेन करने की बजाय वो क्या करेगा, वो लूज करेगा. सो जैसे वो हाइट जो है वो हमारे पास लूज हो जाती है, तो आवर एजेंट इज ब्लाइंड फोल्डेड, और ब्लाइंड या अंधा है या उसकी आंखों के ऊपर पट्टी बंधी हुई है. So it will consider that I am at maximum location, at maximum point. So ये हमें क्या कर देगा, ये खुश हो जाएगा और वहाँ पे टर्मिनेट कर देगा, क्योंकि तो वो ब्लाइंड अंधा है. जैसे वो एक कदम आगे की तरफ जाता है या एक कदम पीछे की तरफ जाता है या किसी भी तरफ मूव करता है, तो वो उसका कदम जो है वो हाइट गेन करने की बजाय अब वो हाइट जो है वो लूज करता है. बट उसका गोल तो इस जगह पे था, लेकिन इस लोकेशन पे जाके वो अपने आप को कंसीडर करेगा कि मैं मैक्सिमम लोकेशन के ऊपर पहुंच चुका हूँ. दैट्स वाई the weakness is of this algorithm is local maxima. It will consider that I will at goal position, but जो है वो ये goal position के ऊपर नहीं होगा. So just look at this algorithm, that we will evaluate new state with the heuristic function and compare it with the current state. If the new state is closer to the goal compared to the current state, so at this point, just look at this point. At this point, the new states are not closer to the goal state because it loses the height. So it loses the height. So just क्या करता है, हाइट गेन करने की बजाय लूज करता है, तो हम कह देते हैं कि वो गोल के करीब नहीं है, क्योंकि हाइट गेन करता जाए वो हमारे पास जो है वो इस जगह पे जाना चाहिए था, लेकिन वो इस जगह पे अपने आप को कंसीडर करेगा कि मैं मैक्सिमम पोजीशन के ऊपर आ गया हूँ. So it will not update current state. So that's why we are not able to apply any operation on this state. So we will terminate our algorithm. So this is the first problem for this search technique. So I will suggest कि आप लोग क्या करें कि प्लेट्यू प्रॉब्लम और रिज प्रॉब्लम इन दोनों को आप देख के आए. हम नेक्स्ट लेक्चर के अंदर हम इन दोनों को डिस्कस भी करेंगे, और इनके साथ साथ हम एक और एग्जांपल भी कवर करेंगे जो कि एक पजल प्रॉब्लम है by using the hill climbing search technique. So I hope you enjoy this video lecture. If you have any question regarding this topic, you can send me an email. I will try my best to answer your question. Thank you for watching this video. Allah Hafiz.